Hello everybody and welcome back to another video by Funlearn Tutorials. In today's video we will be talking about a pretty important topic of discussion under the subject of game theory, which is also again a very important subject in microeconomics. So game theory is a topic under microeconomics, and the topic that we'll be discussing today is called the prisoner's dilemma or the prisoner's dilemma. Now, before I delve into what prisoner's dilemma is, let me just tell you in brief about what game theory is. So what is game theory? Basically, a game theory involves a strategic interaction, so it has to be strategic. I cannot just choose whatever I want to do. There are certain assumptions that I need to follow when I talk about game theory, and it is a strategic interaction, which means the word interaction itself means that there are more than one player. So we cannot play a game by ourselves, right? We can only play a handful of games ourselves. So we need more than one players in this game. And that is what involves game theory. Where does this game come from? The game comes from the fact that what you do depends on what I do and vice versa. So what you do depends on what I do and vice versa. Now what does that mean? Suppose I am considering a game of chess. Suppose I consider a game of chess. Now what happens is, suppose I choose a particular move in a game of chess. Now what happens is, when I choose a particular move, you follow the move that I have played and you decide your move accordingly. You cannot decide abruptly, or you cannot decide haphazardly what you want to do. You have to protect your knights, you have to protect your king, you have to protect your pieces in general, and you have to play accordingly. That determines the outcome of the game. So not just your move, but what I play is also a determinant of the outcome of the game. And of course I assume rationality of individuals or rationality of the players. If I start playing a game of chess with a mad person, of course there is a high probability that I will win, because the person opposite to me, my opponent, is not a rational person, and that way he will not be able to understand the particular moves that I make in a game of chess. He or she will not be able to analyze my moves so as to predict in certain cases what I will play next. And that essentially considers the main it's the main subject of game theory. Basically, it allows two or more players to analyze what each other is playing and decide their own moves accordingly. So now what is the prisoner's dilemma? Our main topic of discussion is actually the prisoner's dilemma, right? Now what is prisoner's dilemma? Essentially, let me just make it a little lighter color so that we can see it properly. Essentially, a prisoner's dilemma revolves around a story. So what happened is, there were two criminals. So let me just write down the story first. The players of the story, there are actually three players of the story. So there are two prisoners. There are two prisoners in the story, and there's a policeman. So there are two prisoners and one policeman. Now what happened is, these two prisoners committed a crime. So these two prisoners committed a crime and they were actually caught by the policeman. What happened is, of course, the two prisoners were denying that they did the crime. They weren't caught red-handed, they were sort of like under suspicion. And the policeman actually, of course, being the protector of justice, he wanted these two prisoners to accept the fact that they committed the crime. He wanted the two prisoners to own up for the crime that they made. And he devised a plan so as to make them confess to their crime. What he said is, he called each of the two prisoners aside in a separate room where there's just one prisoner and the other prisoner is kept in a different room, and each of the prisoners were separately promised that if they own up, then the situation might be different. So what was exactly the promise? Now let me write down the promise. So the promise was as follows. This was promise made to each prisoner. So the promise were made to each prisoner separately. They were not allowed to discuss what they will do, and they have to decide for themselves. So what was the promise? The promise was that if you own up, and the other prisoner does not, if you own up and the other prisoner does not, then what happens is, given that the two prisoners were partners in crime, if one person owes up, the other person is automatically also a criminal, right? They were both partners in crime. So if one person owns up, it automatically implies that the other person is also owning up, but he is not admitting his fault. So what happens is, if you own up, you are being truthful. So suppose this is exactly what I'm trying to show you in this matrix. So suppose this row represents the player 2. So there are two prisoners. So this is one prisoner, the prisoner 2, and this is the other prisoner, prisoner 1. Now what each prisoner can do is they can either confess that they have committed the crime. So they can say, yes, I have committed the crime and I will not do it again. They can confess, or they can say that no, I haven't committed the crime, there must be some mistake, I wasn't even there, or something of that sort, make an excuse and get away with it. Of course, the policeman cannot, since he or she did not catch the prisoners red-handed, they cannot arrest the prisoners if the prisoners do not confess. So they have to wait for some other evidences, or wait for another fine day where the prisoners again make another mistake, and they'll have to leave the prisoners if the prisoners actually deny the crime that they have supposedly committed. So prisoner 1 has two options to make. Either he or she can confess to the crime, or he or she can deny making the crime. Similarly, prisoner 2 can either confess that yes, I have made a bad move, or I have done something wrong, or the player 2, that is the prisoner 2, can deny, no, I haven't done anything wrong. The promise is that if you own up, suppose I'm talking about the prisoner 1. So the policeman has called forth the prisoner 1 separately in a room, and he or she is talking to the prisoner 1 and says, if you own up, so if you confess, if you own up means you confess, so I have to look at this row, right? This row is where the prisoner 1 confesses, because that is how I have marked it. When I look at this row, these belong to the decisions of the first player, which is the first prisoner, and these decisions belong to the second prisoner. So when I say you own up and I'm talking to the first prisoner, it means I'm talking about this row, because this row corresponds to the confessed decision of prisoner 1. So if you own up and the other prisoner does not, so you own up, it means this row, and the other prisoner does not. Other prisoner here means the second prisoner. So the other prisoner does not own up means the other prisoner denies. So if you confess and the other prisoner denies, it means I'm talking about this cell, right? You confess, the other person denies. You confess, this row, and the other person denies, this column. Here essentially what I'm saying is the prisoner 1 is a row player, because his decisions are the row heads, and the player 2 is conventionally also chosen as the column player. Why is he called the column player? Because his decisions are actually the column heads. These are the columns and these are the rows. So when I make a promise to the first prisoner that if you own up and the other person does not, then you are actually given the benefit, because you have owned up, you have been truthful, so you don't get a punishment. First, since 1 comes before 2, here we will assume that if I write 2 numbers in between side by side, the first number will give me the situation for the first player, and the second number will give me the situation for the second player. That is again a convention that we use in game theory, and we will follow up with this in prisoner's dilemma as well. So what happens is, if you confess and the other person denies, the policeman will be very happy with the first prisoner, because the first prisoner has actually confessed to his or her crime, and they actually be let out so as to promote truthfulness and honesty. However, the other person who did not confess, that person is being dishonest. He's not being truthful. So he or she will be punished, and they'll be given suppose a 9-year jail time. Suppose they'll be given a 9-year jail time. Now the thing is, since this is or maybe not a 9-year, maybe it's too much. Let's say it's a 6-year jail time, or maybe let's keep it 9-year. We want the punishments to be high so as to make people good, right? We need to incentivize people to be good. So suppose this is 9. Now what happens is, when we look at the matrix, or when we look at the numbers at a first glance, 9 seems better than 0, right? So it doesn't feel good when you see when you get a 0 compared to a 9. I need to make this 9 seem a bad option, because this 9 represents 9 years of jail time, right? So let me just put a minus in front of that. Now it looks bad, right? Minus 9 looks bad. So what happens is, if the prisoner 1 confesses and prisoner 2 denies, then prisoner 1 gets 0 payoff, because he's not better off or worse off, right? It's not like he's getting a gift out of it, so he's not better off as such, but he's not worse off either. He committed a crime, but he's actually getting away from it, so he gets a 0 payoff. That is, it's not adding to his benefit or something. However, the other person who was being dishonest is actually in a loss, because he is getting 9 years of jail time. This same promise is made to the other person as well. It's made to the second prisoner as well. So if the second prisoner confesses and the first prisoner denies, the person who confesses actually is better off, in the sense that they get 0 payoff, while the person who denies, so this time it's the first prisoner. Suppose now the first prisoner denies, the first prisoner will get -3, whereas the second prisoner who confessed will get a 0 payoff. So this is the situation if both of them make separate decisions. Their decisions do not match up, because remember, these two prisoners cannot meet up. So let me just write that down. Cannot meet up. They cannot decide on their decisions by discussing. So they have to make their own decisions unilaterally without talking to the other person. Now what happens if their decisions match? So what happens if they both confess? If they both confess, yes, they were being truthful, that's right, so they might not get 9 years of jail time, but they did commit a crime, right? So they will be given a smaller jail time. So let's say they'll each be given 6 years of jail time. Again, minus represents the fact that it's a jail time, so it's a bad thing, so you get some amount of loss from it. So it's -6 and -6. Now think about it. If both of the prisoners deny, how can you catch them? You did not catch them red-handed, right? You just think, you are suspicious of the fact that these two prisoners are criminals. So you cannot catch them if both of them deny, right? Which means maybe you just scold them, give them a couple of warnings, and then you have to leave them. You cannot catch them forever. Like, you cannot keep them in prison forever. So you have to give them a lower disadvantage, sort of. I'm taking a disadvantage in the sense that it's -1. Maybe you give them a warning, maybe you fine them, maybe, and then you have to let them go. So it's a -1. Now what happens is, how does a prisoner decide what to do? They have two decisions, confess and deny, but they don't know what the other person does. If I confess, should the other person deny? Should the other person confess? That is what we'll be trying to figure out. And essentially this problem is called the prisoner's dilemma.